Hello, so I have worked a tiny bit on this problem, the problem titled on the Arduino forum, triggering multiple servos and different times without using delay. So this has been bugging me too. Anyway, so the solution I have here is not a final solution, but perhaps it could lead to the final solution. Anyway, so the code here is uploaded to the Arduino board, and at the moment I haven't got anything else apart from one servo connected to ground and 5 volts and digital pin 9. So this code that is uploaded is based on this wonderful link here, gammon.com.au link, and this little tutorial in a way has helped me understand the problems around delay and how to do the non-blocking. Anyway, it's a good read to help understand this. So this code is based on this. Then the main thing I did with this code was I added features in a way of the file examples servo, I think, sweep, right? So I just copied and pasted some parts of this code into this code, hence it's now called LED Gammon Servo 2. It's my second take. Now and you can find the original code here. Now the bits I added are somehow indicated, added by KH, so it is this and this, etc., etc. This one, and the serial begin in the void setup, so we are able to track what's happening with the serial print. So that's one way to debug or troubleshoot or whatever we want to call it. Anyway, then this is an important part here, this void move servo, which is kind of like a sub loop, because the main loop is the void loop. Okay, and in the void loop we have these 3 sub loops, and then these 2 are here for the LEDs. Again, at the moment I don't have any LEDs here, but this LED on the Arduino board is the one on digital pin 13 as well, so I'll demonstrate something with this. Anyway, so there is one main loop here, and I added this part to it, which is triggering, initializing, using whatever this void sub loop, let's call it sub loop. I'm sure there is a better word for it. So I'll just close this, and then what I'd like to do is I'd like to demonstrate how the LEDs still can be changed. So this now is on half a second, 500 milliseconds. If I change this to, let's say, 100 milliseconds, the green LED, well, sorry, the red LED, which is not red, but it's on the board. Oh, I should have changed this. Apologies. Now will flash much faster. Okay, so it's still working. The servo is going to be having the same frequency, going from left to right. Okay, so now the interval for the servo is initialized here, so 500, that's 500 milliseconds, so that's 5 seconds. 5, right, something like that. Okay, if I change this to, let's say, 1 second, okay, so that works too. I don't know what the lowest we can go down to, but I don't think we can go too low. Ooh, it's gonna fly away, so let's go back to 1 second. Okay, now to further explain this, and as you can see, this remained the same. Okay, so there is no delay function in this code. So to further explain this, let's open the serial monitor, because I added some serial prints to the code. So just going back to the loop. So this is the main loop, and in here we do the calculation when it comes to timing, sequencing. Okay, and whenever there is time to do something, this is initialized, evaluated, started, which is up here. So the first thing we do in this code is we print this string, which is just text. What goes in the if? What goes in the if close? Which ends, wait a minute, it ends here. Okay, not here. This is for the main void. So what goes into if else? Okay, I want to find out. So the last thing went in 2000, 1000, whatever. So then if uses this number, right? If it is 1000 or below, then do this. If it is not, that would be like something above, then do this. This is probably unnecessary here because it doesn't seem to go under 1000. However, let's just keep it there. Now, if it is 1000, so let's say I need to explain something else, I guess. I'm using write microseconds instead of just simply write. Oops, let's go back here. So write microseconds is a tiny bit different to just simply write. And then you can read about that in the references if it comes up. Yeah. So basically, if you Google it, you'll find some information on it. The minimum, so 0 as it is with write, is 1000. 1500 is in the middle, so that would be 90 degrees, and then 2000 is 180 degrees, so that's left, centered, right. Okay, so left is 1000, right is 2000. Okay, so these are the two values I kind of use in here. So what it does is, if it is 1000, then what you should do is write 2000 into this variable called position, right? So it's the same that we initialized up here. And then what you should also do is, you should tell the servo to go there, okay? And then if it is not 1000, so then it's probably 2000, then you should write this value in the position variable, and use this variable then to write on the servo, so basically move it. So yeah, I think that probably could help. If it doesn't, then let's refine it. Thank you.